Okay. Good afternoon, everyone. Okay, let's start. So welcome to Ccamp session. So this is Fatai and Daniel. Okay. Look at the loadware information. I think you are familiar with this kind of IETF policies. So I'm not going to repeat this again. And please have a look. And as a participant, we have to follow the IETF policies. So this time we have only one session, but we have 2 hours. So you can also download the slides from this link. So for the agenda, actually this time we have 8 presentations. So with 2 hours, I think we have much more time for deep discussion. So please take your time, or even slowly, and please enjoy your presentation. Any comments on the agenda? Hope everything is okay. Oh, really? Okay, hope so. Okay, yeah. So as usual, we have the audio recording. So please speak in front of the mic and state your name before speaking. So the chairs are in the meeting echo, and we will monitor if there are some comments from the remote participants. And for the minutes, actually, it will be much appreciated if anyone could take some minutes, key points through the Etherpad. And because our secretary Oscar is not here, I would like to ask Hao Mian to help us to capture some key points. Okay, thank you. So for IPR, it's quite very important, and we have to follow the IPR policy in IETF. So we know that if a draft moving to the next step in our working group process, we the chairs will send out IPR polling. For example, before an individual draft becomes a working group document, or a working group document, goes to last call. And so in this case, the authors or the contributors, are required to deploy IPR polling as soon as possible. Otherwise, it will delay your draft. So, for the list, as always, we encourage people to use the list as much as possible. Especially, we encourage people to discuss, especially the technical stuff on the list actively. So, for example, we could, discuss any open issues on the list, or even, for example, introduce some new drafts, or some potential topics on the list. So another important reminder is that working group consensus is determined on the list, rather than in this face-to-face meeting. Even though if we get some consensus here, we will still need to bring it to the list for the wider discussion. Okay.
Let's move on with an update on the status of the working group. So since last meeting, we have a new RFC, which is the data model for microwave radio links. So microwave work is progressing quite well. We have now an RFC for the framework, an RFC for the radio, the young model for the radio link, and we are now, in order to conclude this work, we are still missing just the topology document, which is, by the way, progressing quite well. We also have 2 documents in the editor queue. the alarm module, and the RSVPT bandwidth availability. If I correctly remember, the bandwidth availability is just waiting on the approval on one author, the last one. The alarm module, we are discussing right in these days some comments from the RFC editor, which should be fixed in a matter of days. Working group documents adopted since last meeting, a lot of them. So we have been, you cannot complain your chairs are lazy, because we have 6 new working group documents since last meeting. Mostly we have the layer 0, layer 1 types. We agreed to follow the way of working of these, where the traffic engineering types have been decoupled from the topology, and a dedicated document has been created for them. We did the same for layer 0 and layer 1 types. And the last one we adopted is the client signal Young model. But we have also documents on the WDM interface LMP and parameter, and the new document that we will see today, which is the optical impairment topology model. These are the ones that will be discussed today, for which a slot has been requested. While these are the ones that will not be presented today, but for which we requested an update from the authors. So I'll quickly go through them. If the authors want to chime in and provide us further info, this is more than welcome. Mostly for these two, because we don't have an update.
Right. Regarding the first one, client signal Young, actually we are updating some open issue on the GitHub according to some offline comments received from operators. And we will work according to that kind of issues and update the model.
Okay. WDM interface LMP. Gabriele, Gert, do you want to give us an update on the way forward?
No, we don't have any update, any modification on the document. So I think it's a sign that is quite stable. So
okay. Then FlexiGrid Media Channel Young. This one has been updated to reflect the changes that we were speaking about before, the layer 0, layer 1 types, layer 0 in particular in this case, and some changes regarding the security section and updates to the references. FlexiGrid Young model, again, also this one was updated to reflect to reference the layer 0 types. Layer 1 CSM, no update on that, but if I correctly remember, that was close to last call, right? It was pretty much stable.
Again. Regarding the layer 1 service model, because we have newly introduced the layer 1 types, so the import relationship need to be changed and updated accordingly.
But that's the only pending update, if I correctly remember, right?
Yes. It's not done yet, but we need to do it.
Gabriele speaking. Probably is worth to have a look to the FlexiGrid draft in order to make them more aligned with the IQT last modification.
Okay. Good point.
That is a point that we should work together. Thank you.
Okay. Then, as we said, layer 0 types. Italo, you want? Okay. This has been carved out from the Young topology model. minor editorial changes, changing basically Flex to Flexi. It was agreed to use Flexi as a common term. And there's a new section on TE types module contents to specify all grouping and types. Dieter, please.
Yeah, Dieter Nokia. I just wanted to mention here that we are actually developing this layer 0 types YANG file on our GitHub together with the optical impairment layer 0 topology.
Okay, so probably we need to add the reference to the GitHub.
Probably, yes. Yeah.
Okay.
So both YANG files are there, the layer 0 types as well as the optical impairment layer 0 topology.
Can you send me a reminder? I'll do that. Thanks. Microwave topology YANG. Again, also in this case, pretty minor changes. Moving the microwave bandwidth from T-link to T-bandwidth. Introduced the microwave channel list and removed the tunnel concept. Next step, still some work to be done, but I would say minor one. So clarify the applicability of the T topology on a microwave network. Container definition for microwave TP-link in the YANG model, and complete use case details. No change on the NBI applicability statement. If I correctly remember, last time we said it was time to conclude the work.
Basically, yes, we are doing a detailed review within the design team. We have got many useful comments from Dieter and Michael, and we should be able to have a new update by September, end of August, and then we will be ready for working group last call. The only penny issue is the normative references that most of them are working group documents, and one is individual document, which are normative. So that's
We had this discussion before. This is something we need to sort out. I mean, if those are normative references, there's nothing that we can do. The only thing I would say, we will go for the last call when the document is ready. There's no need to keep it parked until all the references will be published. Probably it will be held by the RFC editor after that. Okay, but at least we will write everything in the stones.
Good, thank you.
No big changes on this document. The only one worth being mentioned is the WSON YANG. Basically, the clarification related to the scope of the document, and the fact that it only covers the transparent WSON. Liaisons and communication, as usual, pretty intense activity to Ccamp and from Ccamp. We received a liaison from ITUT Study Group 15, whose title is related, topic being description of the OTSI and the network media channel. This is probably what we will see in our first presentation from Dieter. And we sent a liaison to MEF on providing an update on our work on L1 service model. This is it. I think we are ready to start with the first presentation.
Good afternoon. My name is Dieter Beller. I am one of the co-authors of this draft providing a YANG data model for optical impairment aware topology. As you can see on this slide, there are quite a number of people who are actually contributing to this effort. So it's a long list, and we are having weekly meetings, open meetings that have been announced on the Ccamp mailing list, given the political circumstances which we have right now. So we have a weekly call every Thursday for 1 hour. And as you can see, we have great support from operators as well as from a variety of different vendors, including, we also have a GitHub. I will come to that later, where we actually manage our Yang files and also manage the open issues which we're working on. Okay, next slide. The scope of the document is actually to provide a Yang data model that actually collects information from the network, from the devices, and constructs a topological view of the network based on the information that it receives from the devices, and provides a network-wide view of the network topology for layer 0 for a WDM network, to be more precise. We have, and this is the picture that's in the document. You can see here, you can see here is the devices in the network, for example, the optical transponders, and also the optical line system segments. So this is just a small piece of the network, and there could be, of course, also ROADMs in this network. The interface or the network is controlled by an optical domain controller. So that domain controller controls all the devices in the network, including optical transponders, ROADMs, optical amplifiers. So all the network elements in the network are controlled by this controller. And the controller actually collects the information regarding the topology and provides this topology information to a client, which can be a multi-domain service controller, or it could be a PCE element that directly has access to the optical network controller in order to retrieve the topology. It's important to note that the information is read-only information, because the information is just collected from the network. We're not intending to use this model to control the network. So, and you can see here, this is the interface that we're targeting, where the topology information can be retrieved. And we have, for device configuration, a separate interface, and there's a separate draft, a Yang model for the interface configuration. That's actually complementing this topology Yang model for configuring the network elements. As already mentioned, we have split off or spinned off the type definitions that we need for this layer 0 topology, and all the groupings that we have defined that are used to describe the layer 0 topology and the optical impairments. So that's in a separate Yang module, and that layer 0 types Yang file that should be imported not only by the topology Yang model, but also by the interface Yang model. So we're trying to get everything pretty much aligned to make sure that what can be retrieved using this topology Yang model, and what can be configured using the device model is consistent. This is the reference architecture, also an ASCII art picture from the document. You can see here we have, for example, the ROADM device. The ROADM devices can be decomposed into an ingress or preamplifier. It has a switching fabric, a photonic switching fabric, to switch optical channels or media channels from one side to the other side. And it also has a drop block where you connect the optical transponders, where photonic signals can be terminated or generated. Of course, between the ROADMs, we have the OTS link and the OMS link as defined by the IETF recommendations. And this we have currently a fairly detailed model of the OMS link. That is a series of elements like fibers, like inline amplifiers, We even have introduced for connectors insertion loss that can be configured or that can be retrieved from the network. So we have a fairly detailed model already for the OMS link. What is still missing and what we're still working on is to define a model for the optical transponders. And we also figure out that we need to define a model for 3R regenerators. So that's still something that's outstanding, and we have created issues on our GitHub for that to address those issues. And refine the model to also include elements for 3R regenerators as well as optical impairments for the ROADMs. Okay, major changes since the previous IETF 104 meeting. Yeah, as you have seen, there are a lot of contributors or co-authors. We had a long list of co-authors on the title page. Of course, this does not meet the rules of the IETF. So we had to select a few co-authors that we put on the title page, and then we moved all the other contributors further down in the document. We also updated the reference documents. We replaced the figures that we have used in our previous discussions, which were PowerPoint slides with ASCII out figures. So and we added also then the definition of what we call here a media channel and a media channel group. The media channel is also defined in the new IETF recommendation G807, and I will come to that in a minute. The media channel group is something that we define in order to group multiple media channels together in case inverse multiplexing is used. That means, for example, if a 400 gig client signal has to be carried using multiple carriers that carry a fraction of the client signal, like, for example, 4 times 100 gig, then it's, of course, the objective to put all the 4 carriers into a single media channel. If spectrum availability doesn't allow that end-to-end, then, of course, we have to split the signals and carry them across multiple media channels, and therefore we have created this media channel group concept. We also had quite some discussion regarding the interpretation of the OTSI definition that is defined in the IETF recommendation G959.1, and the OTSI signal, OTSI group, which is a grouping of OTSI signal that's defined in the new recommendation G807. And of course, we are currently reviewing also all the new parameters that we have added and for the that are relevant for the optical transponders, as well as optical impairment parameters on the line, as well as for the ROADMs, as something that we still have to work on. So based on the side meeting that we had back in Prague, we had a long discussion how to interpret the definitions in the IETF recommendations that define the data plane. Specifically in IETF recommendation 959.1, it says that the OTSI can be a signal which can be composed of a single modulated optical carrier, or it can be a signal of multiple modulated optical carriers. And so we were struggling with that definition, and we actually put together a contribution to the study group 15 meeting that was held beginning of July in Geneva, where we actually said, well, we are assuming for our topology Yang model that an OTSI only consists of a single modulated optical carrier, and we propose to actually clarify that definition in 959.1 to only cover that case and to remove that that it may also contain multiple optical carriers. Unfortunately, this proposal has been rejected, but study group 15 had some discussions during that meeting, and they agreed that they added some clarification into G807. However, we also during the discussion in the meeting that we had yesterday, we still figure out that there is still some clarification required. The G807 is a new recommendation that's currently under, or for which the AAP last call process will be started soon, and we agreed that we will have to prepare some last call comments on that document. and we will coordinate that also in the upcoming meetings of this of the group of people that are working together on this draft to submit these comments to Study Group 15. Okay. This is actually the feedback that we've gotten from Study Group 15 regarding our contribution. So as I said, they rejected the proposal and added some clarifying text to 807, which we still believe is not clear enough. And the issue is actually that they define what they call a network media channel, and the network media channel still has some restrictions which make it difficult to actually optimize spectrum utilization. So that's the point that we will have to clarify and discuss in that AAP last call on 807. Okay, based on the feedback that we got in that liaison letter that Daniele has mentioned a few minutes ago, I think our model is still valid, and I think we can actually, we believe that we can move forward with what our assumptions are. So we believe that the current Yang model is aligned with G807, and the assumptions that we have taken in our draft is that, as I said, that an OTSI only has a single modulated optical carrier, and we also allow the freedom that the frequency of that optical carrier may not or be on the ITU-T grid. That allows us actually to squeeze multiple carriers together into a media channel to optimize spectrum utilization. And a media channel can contain multiple OTSIs, so for the purpose of optimizing the spectrum in case inverse multiplexing is used. And all these OTSI that are belonging to a single OTSI group have to be co-routed. So therefore, the requirement from our side is that the network has to provide a pipe end-to-end from A to Z, crossing multiple ROADMs where the media channel of the same size is switched in the switching fabric or in the WSS switching matrix, and such that we get an end-to-end pipe that contains all the OTSIs belonging to the same OTSI group. So that's a pipe of the same size from A to Z that carries all these signals. Okay, as I said, we still have to work together with the ITU-T Study Group 15 to clarify these issues. And as I said, we are going to coordinate and send some AAP last call comments on 807. This is the Yang, the tree view of our topology Yang model we have currently on our GitHub. It augments the TE topology Yang model, so it's augmenting, for example, the TE link attributes. Here are a number of attributes that are listed. So for the OMS line, for example, we defined the generalized OSNR, some power parameters, then the media channel group and the media channels inside the media channel group. We also, for the OMS line, we defined the elements along the link from one ROADM to the neighbor ROADM, so that those elements could be an amplifier, could be a piece of fiber, and could also be a concentrated loss, so which is introduced due to a patch panel or some connectors. And the other augmentation that we have defined so far is for the termination point, the attributes that are related to the transmitter and receiver in the optical transponder that defines, for example, either a standard mode in which the optical transponder is operated, or an operational mode that's defined by the vendor. Excuse me. Or the third option is actually to explicitly configure the optical transponder attributes like the modulation format, the baud rate, the forward error correction that's being used by the transponder. Yeah, we have at GitHub. We are using GitHub to actually develop our Yang model, our Yang file, and there are a number of issues there, and everybody has access to this GitHub and can actually create issues or submit pull requests in case he's proposing some changes, which we are then reviewing together, and then we're if the changes are okay, we're accepting them and then move on. Please have a look. This is the link to the GitHub. It's also, I think, available on Data Tracker for our layer 0 topology Yang model. So if you go to the Ccamp page, you find also the link to the GitHub there. Currently, we have, or we had 24 issues up to now. 12 are closed, and the remaining 12 are still work in progress. The most important issues that we're currently addressing is we need to define what the OTSI capabilities or the transponder capabilities are. So all the operational modes and the configuration that possibilities the optical transponder provides have to be defined and have to be retrieved in order to support path computation on the topology. Because when you create a new service from A to Z, of course, the two transponders at the end of the photonic connection have to have some capabilities in common. Otherwise, the traffic or the connection doesn't work. So in order to make sure that we have to list all the capabilities that the two end transponders have, and also the optical impairment parameters determine to some extent also the length of the connection or how many ops you can actually cross, and those also depend on the operational mode. So that's important information that has to be provided before the service is actually established. And then, of course, the optical transponder has one configuration based on its capabilities. We still have to define what optical impairments should be provided in the model for ROADMs. So when an optical signal traverses a ROADM, we have to define what optical impairments in terms of crosstalk, for example, or other impairments. So those are still missing. And the last, or one of the other important open issues is the definition of 3R regenerators. We had some discussion yesterday already. There are different types of 3R regenerators, unidirectional regenerators or bidirectional regenerators. So these kind of devices that are used in today's network have to be supported by the model. Next steps, of course, we will continue our discussion or interactions with the IETF, as I said. We will have to keep the alignment of the topology model with the interface model that's going to be presented in a few minutes by Gabriele, and of course we'll have to add then also the model for 3R regenerators and manage the open issues on our GitHub. So that's pretty much it regarding this draft. Questions?
No question. Gabriele.
Actually, Gabriele speaking. Actually, it's not a question, but is a recommendation. As when we introduce, for example, 3R regenerator, also the layer 0 type draft should be updated accordingly. And then, okay, we are working with the author of the draft in order to make or keep that draft in sync with our draft.
Okay. Okay.
Yeah, I think that's our general strategy, that we have one Yang file that contains the type definitions for all the layer 0 work, including the topology model as well as the interface model.
Yes, absolutely.
To have a single source that's imported then into the Yang models for the interface as well for topology. Yeah. And maybe there are others.
No, just to reinforce again the message, go to the GitHub, because in the GitHub, actually, we put all those documents, and then you can see how they are aligned, and then we make it easy to manage all this stuff and to keep all this job synchronized together.
Okay, great, thanks. So, Dieter, this is the first time, so I have one comment for clarification. Could you go back to page 7?
This is already the next one.
You already changed?
Oh, we have time, you said, all right?
Yeah, we have time.
We have time, but we are 5 minutes late after 2 presentations.
Ooh,
One quick comment. Okay, so could you?
that was fast.
Could you move back to page 7?
7, here we are.
Yeah. So here, regarding the assumptions, I think actually these 3 assumptions are correct. But based on the ITOT recommendations, it says that OTSI may consist of one single carrier or a group of carriers or subcarriers. So for the first item is correct, but I'm not sure. My question is that if your model can support OTSI consist of a group of carriers or subcarriers.
Yeah, we deliberately did not want to have that because we believe that it's sufficient to have an OTSIG that can contain multiple OTSIs. And to have a second level of inverse multiplexing. And that was the message or the proposal or the justification in the ITOT contribution. We believe that this overcomplicates the management of the WDM network.
Yeah, I know your purpose of your contribution to ITOT, but this contribution or proposal was rejected in ITOT. I mean, so because in IETF actually we don't define the data plan technologies. Usually from the control plan perspective, we should follow the ITOT recommendations. So so in this case, if it is not consistent with ITOT recommendation, how we can handle this issue? Because anyway, ITOT does not modify the definition of OTSI based on your proposal, right?
That's a good question. On the other hand, if you look at the optical transponders that are available today, I think all the vendors are actually using a single optical carrier that's modulated to carry digital information. So in the liaison statement and also in the information that I received from the ITOT meeting, they said in the future there might be other modulation techniques that may use subcarriers, but today I think such modulation schemes do not exist in real networks. So therefore, I think we're okay for now. And in the future, if required, we can of course extend our model.
Just to add to the question in progress, so maybe we can take it to this later. But the ITOT has a term to refer to cars, and we want to talk about blue cars. So we agree to reuse the ITOT term cars to refer to our blue cars. If the ITOT want to refer to other type of cars, we don't mind, but our model is just about blue cars, and we name it blue cars because we wanted an ITOT term to refer to blue cars. If it doesn't suit you, we may come up with another term, but we will add some more discrepancy between our document and ITOT terminology. We felt it wasn't necessary because a blue car is a car. That's it.
Okay. Moreover, we are not redefining the concept of OTSI. It can be composed by one or multiple carriers. We just support the way of configuring one carrier.
Exactly. I mean,
this was the legalese part.
Gabriele speaking, the point is that even if we choose to model multiple carriers inside the OTSI, honestly, we don't know how to do that. There is no application for the moment. But of course, we are quite open to do that as soon as the chance.
But nothing prevents us to say the OTSI can be composed by one or multiple carriers. For the moment, we define how to have a single carrier.
Yes,
Exactly.
That's fair.
I don't see it as an issue.
That's our assumption, yeah, exactly.
Yeah, probably be careful when writing in the draft something like, don't write, we assume that only a single carrier can be part of an OTSI, but say something like, an OTSI can be composed by single or multiple carriers. Within the scope of this document, we are considering just the scenario of single carrier.
Okay. Yeah.
Also in the IETF, the feedback from IETF is that anyway, the management entity, the controller entity is
a single entity.
Yeah.
Yeah.
So the fact that it's one or multi-carrier does not matter, because the entity that has to be managed is the OTSI. And this is perfectly aligned with what the draft is saying.
Okay, good morning. This is Gabriele Galimberti speaking. Okay. So this draft is actually complementing the previous draft described by Dieter, and is working more at the lower level. So represent the optical impairment at the interface level. So while the previous draft is augmenting the topology, this draft or the models described in this draft augment the interface, the IETF interface models, so that the scope is to give the possibility or expose all the optical impairments models and the way that an interface, DWDM interface works to the controller, basically. Document history is just quite a new working group document. He has been promoted to 00 version in March, so we didn't have any presentation in Prague in IETF 104, and has been updated in July. What has been changed is they rename some parameters that are reflecting better the meaning of the signal they represent. We added actually two new parameters. One is the baud rate, and the second one is the total input power received at transceiver. Then we fix some typos and so. So the next step is, okay, realign the document based on the latest IETF definition and models. Work very close to keep the draft in sync with the optical impairment topology young models, either in terms of terminology and in terms of contents. So I remind that these two documents are complementing each other. So it's important that they have the same terminology and they don't present any parameter duplication, because this would be misleading and so on. Okay, for the last call, I think the fate of this document will follow the fate of the topology young document. So there is still quite a lot of work to do because this one will be affected by 3R generator and again, probably the enhanced modulation format study we are going to start again and all the stuff. So, of course, not asking the last call, But I think what I'm asking is to have a look to the draft and then to provide feedbacks on the contents and on the parameters that we have modeled. That's all from my side. Any question?
Please get going. I'm also a co-author of this draft. Just to clarify, so in this interface model, there are also the possibility to define different carriers, which is to address your concern. We still need to work out how to, let's say, bridge those two drafts together. But at least from that perspective, we're okay.
Thanks.
Thank you.
So one quick comment. So do you think this draft needs to be reviewed by young doctors?
Yes, that is
But not yet.
not yet reviewed
Yeah, not yet.
by young doctors.
So you mean before the working group last call, we sent the
Absolutely.
to young doctor
Thank you.
review?
Thank you for
Okay.
reminding
Thank you.
that. Actually, I was going to write in the presentation, but I forgot it.
Dieter, just a suggestion. Would it make sense to also put this draft or the Yang model of this draft onto our GitHub? Because you said they go together. We could actually think of putting them on the same GitHub, and we ensure that they are consistent and that they're reviewed by the people who are contributing to this effort.
Absolutely. Excellent suggestion. Okay. Thank you very much.
Thanks. Aumian is next.
Okay, this is Hamian from Huawei, and welcome to Layer 1. So the first draft is going to be presented is Layer 1 types, which is a new draft, but this is agreed in the Prague meeting to have a common session between among a few drafts, including the OTN topology, OTN tunnel, and also the Layer 1 service model. So we generate common types and groupings and put the model in this draft. So firstly, let's look at what is the proposed model relationship. And the motivation is to use the same philosophy with what has been done for T generic model and extract the technology specific model, the types the common types between multiple models. So here we just focus on Layer 1 and more explicitly OTN common types. So this model would be imported by 3 different modules, including the OTN topology, OTN tunnel, and the Layer 1 connectivity service model. And this module itself does not require any importing from other models, so this can be used as a fundamental one. And in this table, we just enumerate what has been included in the current Layer 1 types. So there are 2 groups of basic type. The first one is audio type, and the second one is client signal. So basically, audio type is used as a switching type, and we are using, we have specified all the audio types listed in RFC 7139, which is based on ITUT G.709, and also the RFC 7963, which is from the Supplement 43. And for the client signal, we have different granularities for Ethernet, STMN, OC, fiber channel, and FICON. So we have a reference to the corresponding data plane standard as well. And besides the types, we are also having similar groupings which would be imported by multiple models, including basically, besides the audio type and the client signal, we also have the label information, bandwidth information, and also some encoding functions. So from this table shows which model import or use which groupings. So there is consecutive effort to harmonize all the layer 1 models, especially for the OTN1, and make it consistent between OTN topology tunnel and layer 1 connectivity service model. And there is also the open issue to check with RFC 8407, which is a guideline of the young model, to avoid annoying Mr. Patch. And after we do that, we will request for the working group last call and the young doctor review. So any comments so far regarding the types?
Just a comment from let me say, a process point of view. I would say that now the flow to be followed in progressing the work should be types, topology, and tunnel, like they did in teaser. So yes, this will be the next. The layer 0 types and the layer 1 types will be the next in the pipe to be moved forward.
Right. Yeah, just so the slides is also following this order. I believe it's correct. So after the types, we are going to present the OTN topology young, which has been silent for a while. And last time is Montreal again. So let's review the summary of the changes. This is now is version number 7, but what we compared is version number 3, which is our last presentation in Montreal as well. So for this work, we have checked the compliance with the 8407, and we corrected a few places to make the model complete and make the draft all the sessions with sufficient information. And we also changed the model according to some open issue on the GitHub. Firstly, we added the supported client signals to indicate the capabilities of the OTN node. And we also harmonized with the latest T generic model, which is now in the RFC editor queue. And basically, there are two basic classes. The first one is to add the label step information, and for OTN, so since it's a digital ones, and it is always set to 1. And we also change the path, corresponding paths, according to the latest T topology. Finally, with emergence of layer 1 types, we switch the importing from layer 1 types instead of OTN types. So this page, we give a summary on how we augment each part of the T topologies to specify the OTN specific characteristics. So basically, for the attributes, we extend the link and TTP a little bit. And for the bandwidth, we use audio type and the numbers to indicate each of the audio as a list. And a few parameters, including TPN, tributary slot granularity, and list, are added into the T label to indicate the label start and the hop and step restriction step. So this work is technically stable, and we also request for the last call and the young doctor review after the previous one. It is worth noting that the model is now available on the GitHub, so everybody is welcome to review and provide your comments. Again, questions for this one?
I'll have one. So the young doctors are pretty much overloaded with reviews, etc. Isn't the T types something quite simple that we can skip the young doctor review? Do you feel comfortable to progress the draft without a young doctor review for such a simple draft?
I'm trying to understand whether I am the right person to answer.
I'm thinking about if there is another direction of that question. Does the young doctors actually need to see these to be able to review the other documents? It's a question, I don't know.
Probably.
One hint I would like to have is it would be much more efficient if we have the same young doctor review the topology and the types
For
together.
sure,
Yeah.
for sure. I don't know if it's possible to ask for a cluster review, something like put this together with the topology. Probably, I'll try to dig a little bit into data tracker to see if it's possible to do so.
I'll try to answer to Laura. Yes, these layer 1 types are used by topology and tunnel, and it needs to be understood if you review topology and tunnel. And I don't know if you can. Well, I heard that the young doctor review has to be done anyway before we go to RFC, but I'm not sure. That's a question to you.
I don't know the answer.
Okay, Michael from Huawei always focused on the NAMO folks, and I know the young doctor will like to review such as types of what have modules such as the interface types and another types. I think the young doctor like to do these works.
Happens. You got a question from Future Way. So we went through this process with many.
Could you louder? Sorry.
We went through this process many times already, and I recommend, if it's possible, then to do it and to do it as early as you can. Okay, there is a lot of good feedback comes from the doctors. Okay, with respect to readability and also with respect to legality and correctness of the definitions. This is an important thing, because if you don't get it right, then many models that depend on that will be also affected. Right. So also they sometimes require different references so that it's clearly understood. So I would say, yeah.
Thank you, Igor.
So, Low Anderson. About doing a cluster review, it is possible, though not immediately in the tool. You have to talk to one of the people running the process. And then you actually request the reviews immediately after each other and cross-reference in the...
Thanks.
So okay, then the next one is next draft is a young model for OTN tunnel, which is also related with the previous two and mainly imports the layer 1 types. So we have also did some change to the text and the model. So text is basically format checking and make every section complete and compliance with RFC 8407. And the young model change, we also harmonize with the TE generic model. The same is similar as OTN topology. We add the OTN label step and change the path to be consistent with the latest T-tunnel model. And we switch importing from layer 1 types instead of OTN types. And the final one we would like to mention is we have removed the RPC for path computation after we negotiate with the authors on the path computation in the TIS working group. They have a very generic framework for how to do the path pre-computation, and it would be by default to follow that one. And for the OTN specific part, we will leave it out of this document. And similarly, we are augmenting the TE tunnel model in a few different segments. The first one is the attributes. We augment T tunnels. The T bandwidth, we also indicate the audio types to represent the bandwidth information. And again, TPN, TS, TSG, TS list, range type, such kind of things on the representing the OTN labels. So basically, this is consistent with what we have been doing in the OTN topology. So the next step, this work is also technically stable. We cannot see any potential change unless there is a change on the generic model. So we are requesting for last call and young doctor review, as Igor suggested, to start as early as possible. So we also need to wait for the generic models to be published. And we have the same GitHub for this one, for all the three young files. And that's all.
Okay. I confirm what I said before. We will go for the types topology and then this one.
Okay.
And if possible, try to cluster them together for the young doctor review.
Sure.
Italo, you're next, right?
Thank you. I'm Italo Busi from Huawei. I'm presenting on behalf of co-authors the draft on Ethernet and client topology. Oh, okay. Okay. So what is the problem statement? What is the problem we are trying to address with this draft? Is two problems. The first problem is to describe the Ethernet access link. So what do we have defined up to now is we have a T topology and T tunnel models, which allow to set up a tunnel in the network for any type of server T network like OTN. And after we create this OTN tunnel, for example, we can map, thanks to the Ethernet client signal, we can describe how the Ethernet traffic from the access link can be mapped and transported over the T tunnel. What is missing is what are the access links? How to represent these access links in terms of topology, how to describe the interlayer relationship between this access link and the server layer TTP, because if I want to create a tunnel to carry traffic from that enters from a given access link, there should be an adaptation capability between this access link and the TTP, otherwise the traffic from the client cannot access the tunnel. And what are the capabilities from the access link in terms of VLAN classification and operations, which have to be configured in the client signal model. And one requirement we have, for example, in MEF, people want to configure per UNI bandwidth profiles, so how you can configure a bandwidth profile on an access link. And the solution is to have a client topology for Ethernet, where we report the access links, and the interlayer relationship, we can use the interlayer lock or the transitional link approach, which is a general approach and will be adopted for indicating the interlayer relationship between the Ethernet client and the server T topology. The second problem statement, we are trying to address. That's interesting. I'm sorry?
No, it doesn't work either from here.
Oh. Okay. Next one. Okay, it's basically support topology discovery for an Ethernet TE layer. So you want to discover all the network, the links and the nodes which are capable to switch Ethernet tunnels, LSPs, and you can use this for power computation and tunnel setup of those LSP. So basically, it's providing is yet another technology-specific augmentation of the generic T topology model when the switching technology is a layer 2 switching capability, and this type of switching technology is a generic T, can be also used to support the Ethernet client signals as before. And that's yet another technology that we can use, and we can represent in the same topology both the server T and the client topology. Next, please. Oh. Okay, so what was the approach that we did is basically to create this new one topology model, which provides both the and client descriptions as an augmentation of the generic T topology. Next. And that's okay, we can go quickly here. It's the augmentation. So what is the next steps? Okay, this approach is quite consistent with the existing IETF models. The T is just an augmentation of T topology, where the client is basically providing the capabilities that are used by the client signal, which has been recently adopted as a working group document. We are relying for problem statement number 1 on this document also in the transport and BI design team to represent the access links to carry services over OTN. So we think we can start, we can move this work to the working group and ask for a poll. And this work is also available, and we use the same YAM model as before with OTN and other seniors. And one doubt that we got recently is whether we need packet T types and packet T topology has an impact on the concept, on the structure of the document. I think this can be addressed by the working group, and we need to, I'm still discussing with the authors of those drafts because it's not very clear whether they are generic or MPLS-T specific, these two documents. Okay, thank you.
Questions? While people go to the mic, I'll make a quick one. Why TE topology and not topology?
Yeah, good question. The reason, yes, the reason for this is that there are some attributes in the T topology which can be useful for us. For example, the interlayer lock, which allows you to link the client topology with the server topology. You have also information about the client ID, server ID, which is who is exposing this topology, and also you have the plug ID that you can use if you want to stitch a dual access links topology between two different domains. These are, I think, the 3 major reasons.
Makes sense. Tarek.
Thank you.
Tarek from Juniper. So back to your diagram where you had the access links and the underlay.
Yep.
It's not clear which one you're trying to. So the Ethernet links are in the underlay.
Previous one. Previous one.
Ethernet is a service layer.
Yes. Yes.
And underlay is MPLS, for example.
Or MCS, or OTN, or or WDM. Yeah.
So the topology would be the overlay topology or the underlay?
This one is the topology of the server.
Okay, so both. You're modeling both.
Yeah.
The server and the client?
And the client, yeah.
And when you're modeling L2, how is it different from any L2 topology, basically? Is it L2 VPN kind of service topology?
Well, Q VPN. Yeah.
So in L2, I mean, maybe I'm not expert too much, but there is, you don't, how do you establish a path? Normally it's STP establishing a path. It's not TE constrained path in L2.
Oh, this is for when you want to do a tunnel. The problem we are trying to address is the client signal over traffic engineering tunnels. So you set up a T tunnel and you want to say which traffic goes, that you want this particular traffic to go over this T tunnel.
Okay, so it's just a 2 access links.
Exactly.
And underlay and
tunnel. Yep.
It's not a L2 topology.
No, it's just describing what these are the access link, because I want to say the traffic that enters the network from this access link with VLAN number 10, I want this traffic to be carried over this T tunnel up to this access link with VLAN number 20.
Okay, and the approach they've taken is we have a tunnel, and then we have a service.
Yes.
So there cannot be any switching in between, you're saying?
No, I'm saying there could be two. Maybe they should be divided to a service model and a transport model. Right, where the service is the access links, and then you're tying them with your.
Yes, this is the Ethernet client signal that is basically telling that that is clarifying how the traffic is here, right, and which is the tunnel that you are using. The problem is when you say which link. Where is the link?
It's an L2 VPN service.
Yes, basically,
Meth. So in L2 VPN, they have L2 VPN's service model, and then they have the tunnel model, and the tunnel is separate, right? What you're mixing?
No. This is not separate. It's still separate. You have the tunnel model. It's the T-tunnel model, which can be OTN. But the tunnel model sets up the tunnel from this point to this point. Sure. Now, what you have to say is you have to say which traffic goes here, and that's the client signal. The client signal reference to a link. What is this link?
So just specifying the reference link.
Yes. What is the link and what are the capabilities of the link? And then make sure that the traffic that goes from this link can access this TTP, because otherwise I set up a tunnel which is not reachable from the access link, and I cannot use that tunnel. Okay, thank you.
Igor, just a clarification. So basically, we're not talking about layer 2 service per se. We're talking about T aspect of layer 2 service, right? So for example, if you have layer 2 VPN, which has some kind of T constraints or optimization, then you will do that.
Yeah.
Okay. So it's not about reachability per se. It's about traffic engineering aspect. This first thing. The second thing you can think about this is basically a one-hop Ethernet link, which basically supported by end-to-end tunnel in the server layer.
Yeah.
Right. But there is also important use case when it is not just one end-to-end tunnel, but say a couple of tunnels with some node in between which do regrooming, not necessarily Ethernet switching, but regrooming. Okay,
you are talking about something like service stitching?
Yeah.
Okay.
So for example, I cannot do end-to-end OU4.
Oh, no. Okay, there are two cases. That's why we have the second problem statement. If you cannot do an end-to-end OTN tunnel, then you have a node. Then you have basically, in principle, two types of options. One option is that the end-to-end tunnel is an Ethernet tunnel. Mm-hmm. And then that's why you have the second issue, and then you have to manage an Ethernet topology and an Ethernet LSP. So what you do, you create the two OTN tunnels becomes T links in the Ethernet topology, and then you set up an Ethernet tunnel, but you still have to steer the traffic from the access link into this Ethernet tunnel. So that's I say this document addresses both. You can expose an Ethernet topology, which can be built on top of an OTN topology as well, as a multi-layer topology, or as you can deploy it as just Ethernet switches, which support Ethernet LSP. The topology is completely independent. And then but even if you don't have this type of topology, if you have only OTN, you still have the problem to discover the access links. So the two problems are orthogonal.
It's not orthogonal, it's just one is a trivial case of the second.
Yes. Okay.
So basically, what you are saying, I understand, is that you in most of the cases you have a single, say, end-to-end tunnel, which basically supports a one-hop link, over which you will deliver service. In more general case, it doesn't have to be a single tunnel, but it could be, say, 2 or 3 with nodes in between, which basically can terminate, say, tunnel, regroup the service and put it back. So in this respect, they are not so much different from Ethernet switches, except they have like a rigid, switching capability from left to right. Yeah. And in yet more general case, you have like a free switching, which is like a more comprehensive Ethernet topology. But you're not talking about this. You're talking about the first and the second, right?
Yeah. Okay. Thank you.
Thanks, Italo.
Thank you.
Where are the blue sheets?
Okay. Okay. Hello, everyone. This is Chile. I'm going to present this presentation. It's about how to apply the GMPS to the beyond 100 gig OTN. Next, since the adopting of this draft, we make some updates. I think these updates are based on the comments just before the adoption. First, the update is some description about how to represent the OTUC link with T-link. We add one finger to try to describe this. And the second one is it's based on the comments from, I think, maybe last year in Bangkok meeting. We add some text about how to know the attributes of the ODUC T-link, which is whether this is an ODUC4 link or it's an ODUC2 link. We just add this. And also, just after we submitted this draft, we also received some other comments. The first comment, I think, is just about the case without a 3i. That I think we should add this to describe the representation of ODUC link with T-link. Also, we received some comments about the text referring it's try to align with some other document, not to overlap with the currently like ODOK writing document, like such kind of comments. Okay. Yeah, this presentation, I think it's pretty simple. Any comments?
Quick, thanks. Loa. Take your time. Quickly.
I'm not moving fast. Take your time quickly. Are the animations there? Yeah. They are? Okay, thank you. So time to put the clock back like 3 months, and we are now in the Ccamp session in Prague. I actually requested a slot in Prague, but never happened, and Daniele claims that it's because he doesn't read mail. We spoke across each other, so I didn't get the slot. This is actually what I would have presented in Prague. So what happened since last, like the meeting before Prague was that we posted a new version of the document. We restructured quite a bit based on comments, including comments from Daniele. We put the interface and sub-interfaces back in, moved all the requirements to the agenda, and a lot of spelling errors and other grammatical changes and things like that because of comments we got. We say that the document is now, or was 3 months ago, reasonably stable. We have made improvements to the document, but not really any technical changes. This is a picture that has ASCII art in the document. And this is I think, the weak point of the document. I tried to come up with a reference model. I need help to go over this model and see if it's actually correct. I think I have had cross comments on it. So people saying, this is correct, you should do it like that. No, this is wrong, you should do it like this. And so this is a kind of a compromise. But anyone that can grab me in the corridor or send me a mail and actually discuss this reference model, please do so. So we put the terminology as using, we actually going back to RC 4201, where link bundles are actually defined as logical interfaces on a router. We actually do the same thing with flexi group and flexi links on these boxes here. It's been in and out. I think this is the second time I put them back in. Well, yeah. We've been asked to put stuff into the document, what we want to do. And here's a list of what we think a GMPLS control plane for Flexi can do. We can set up Flexi group or as an Ethernet interface. We can set up a Flexi client as a Ethernet sub-interface. We can advertise those interfaces into the routing system. And we can actually set up an LSP on top of those, the Flexi network. And if we go to real life deployment, we could use all of this, part of this, any subset. And we can actually control the network, not only through a control plane. We can also use an NMS or a centralized controller, or we can be model driven if we want to. Anything is possible. And actually, I think any combination of them is also possible. That line break was not in my slides. That has been introduced. So when we do Flexi configuration, we have a lot of alternatives. I said in the previous slides. We can use an NMS only, set up everything down to the last bit on the MPLS LSP. We can use a combination of the NMS and GMPLS control plane, or any type of the method we discussed before. There is an available signaling channel in Flexi that we have as soon as we have a Flexi group. It's possible to use that. So once we have configured the Flexi level of the network, we need to export that to the routing system to be able to use it for efficient routing of any service on top of the Flexi. No, there is no animations. This is almost impossible. Do I have a? Yeah, okay. So let's start with an example where we have an NMS or a controller. So the controller talks to the shim on both ends. A Flexi group is established across, and then we leave the Flexi client out just for in this example. But this information could be exported to the control plane and then to any routing system that we have. And then, yeah. So then we have a network where we have a mix of Flexi capable links, they are blue, and of non-Flexi capable, they are yellow. And you want to, it's kind of playing a trick with me. So you want to set up a connectivity from here to there, and the straight link where you could go if you only used cost metrics would be going across from here. So now we introduce the condition that we actually want to use Flexi capable links all the way from A to B, and then we actually get something that traverses the network that way. I don't know if it's the best. You can find a better way, but I don't think so.
Laura, a question for clarification before you move on. So this is a collection of flexi links, or is a flexi link from the ingress to the egress?
So one thing that we actually said like 200 times in mails to the mailing list and in the presentation here, a flexi link
is not switched.
Just between two boxes. It originates in one box, terminates on the other. But in the control plane, you can see which boxes that has flexi links attached and to which boxes go. So you can pick interfaces. Someone called it daisy chaining. I think it was Dieter. But that's what we do. But that's what you do always on Ethernet. You're doing exactly the same thing. You say you want to have an Ethernet link with the following characteristics, and then you do daisy chaining across to get over to the other side. Yeah, okay. So next steps, well, since we didn't present it last time, we kind of did go and hibernate for 3 months, and now we're back here. I'm prepared to work further on this, but just now it's kind of hard because I need the input from the working group. And the only way to get that is actually making a working group document. And we have other flexi documents that actually depends on this. So we should really make it a working group document quite soon. I think I'm done.
Let's go to questions before polling. Please.
My question is, the first question I think is, can flexi client be defined as a network layer?
Can you repeat?
Can flexi client be defined as a network layer?
Can flexi client be defined as a network layer? I don't really think so. Okay. But the collection, that was
further.
That one?
Further. Go further. Yeah. I think you try to use SDP to set up a flexi client connection.
Sure.
Yeah.
Same way as you set up any other link.
Yeah, but if you do this, I think you just want to model flexi client as a layer.
The thing I think we can model as a network layer is the collection of existing flexi clients in a network, not a single link.
Okay, let me ask a question in another way. If I remember correctly, that in current flexi data plan standard, there is no information like source address information or destination address information defined for flexi clients. Without this, how can you create a flexi client connection?
I don't really get the question. Anyone can help me?
No.
Could you repeat your question, Chile?
Okay.
Take it in Chinese if you want.
Sorry?
Tell that in Chinese.
If it's easier, why not?
So currently in the flexi data plan technology, I think there is no essential information like the source address or destination address defined for flexi client. Without this, how can you set up a flexi client connection? It's just if we took a look at the
So how do you do it if you're model driven in a Yang model?
We just model this with a client identifier.
So we have the identifiers here also. That's what.
But we don't define this as a layer. It's not a layer.
So you're saying you can do something with the same link, the same identifiers. You can do it in Yang, but you can't do it with a control plane. That seems to be.
If I understand correctly, if we want to set up the connection with the SVP, that should be switching type, including if these are included. I think the most important thing is to say if this can be a layer.
So that's when you start working on the signaling part and the routing part. We need to define those things correctly. It has been done before, so why couldn't we do it here?
So we take now Julian, and then we have a remote question.
Could you go to the next slide with the network, please? Here I'm confused with the use case you depict here. Why would I, as an operator, set up an LSP over flexi capable links or not? Here, what I would need is I have a 200 gig service to set up. My LSP is 200 gigs. What I care is the bandwidth on the link, whether they are flexi capable or not. I need 200 gigs over blue or yellow links. I don't care if they're achieve 200 gigs with flexi or not. It's a matter of setting up the capacity between the neighbors using flexi or not. But I don't see the use case of setting up an LSP over a flexi capable set of links. What's the point here? I don't see the value, sorry.
Okay, so I think that question is one of the questions we really had to address. The thing here is that my assumption is that FlexE links have a bandwidth that is way, way bigger.
Then have the bandwidth on maybe sometimes it will flexi capable link that will be selected by my past computation, sometimes not. But whether I build my link using POS other base Ethernet interface,
wait, you kind of interrupted me. So I say it's a way, way bigger bandwidth, and it's possible to split them up in granularity. So you can actually allocate bandwidth on a flexi client for a specific purpose. And you can't do that on Ethernet, on the regular Ethernet. So in regular Ethernet, you mix packets over the same link. In flexi, you can send traffic on a dedicated bandwidth that is just for you.
Between my flexi group ends, which are probably between my two neighbors. Or
you can send it all the way over. On a particular flexi group, you have a flexi client that has a certain bandwidth. We can give you all that bandwidth to you only. And there's no way of doing that on the regular Ethernet. And that's a point with the flexi, I think.
It feels to me that you will define flexi as a kind of what we used to call that GELS, GMPLS label switching, or kind of connection-oriented Ethernet, which is not the way I'm understanding flexi today. So that's why probably I'm confused.
Dave Sinicrow from Ericsson. I'm kind of with Julian on this. I mean, how is this any different than what we have with GELS and Ethernet today? The flexi is not.
No, we don't have GELS.
Okay, well, all right. But I mean, we did GMPLS switching for PBPTE at one point.
If I had.
Sorry. So my understanding of the flexi links is that the flexi is not visible to anything above the Ethernet 6466B. right? So how does any kind of control protocol know that it's even talking about a flexi link?
We make it visible.
Oh, so we're not going to use the OIF. We're going to make it visible.
Well,
So
on
it's
the control.
not really flexi, because the whole thing behind flexi was that it was hidden underneath Ethernet. It looked like Ethernet to the upper layers. So you're saying this isn't quite flexi.
It's flexi. You define a flexi client over your flexi group. That flexi client is visible for the control plane.
So according to the OIF, it's an Ethernet client that uses a flexi on a link. There's no flexi client. Flexi is configured underneath the Ethernet. And it's done on a very coarse granular basis by configuration. So the idea that it's dynamic and we can switch the bandwidth, with a control protocol, to Chili's point, which I think I understood, there's no handle for the control protocol to get a hold of unless you're exposing it out of the 6466B layer, in which case it's not OIF flexi and it probably violates 802.3.
So what handle do you use if you use it from a Yang model?
I don't. I configure.
You don't?
I coarse grain configure it statically in that box and that box, and it works until I change the configuration in that box and that box. The same way I would forget the Yang model if I use a proprietary data model. It works the same way, but there's no control protocol to do anything with it.
Igor, let me try to help you. I think you're talking with these guys on different levels. Okay, so it is true that on the upper client layer it's just Ethernet, right? But for example, how to actually implement this Ethernet, it's a different story and require different orchestration or control mechanism. It's just like, for example, when you orchestrate, say, layer 3 VPN service, from the client point of view, it's just layer 3 VPN, but from the orchestrator point of view, it's many different other things, including setting up tunnels and steering services and so forth, right? So if I understood you correctly, you're talking about the latter, basically, orchestration, the support for flexi. Is my understanding correct?
I think so, yeah.
Okay, then it's basically it answers both Julian and David, because they're thinking about from the client point of view, it's just pure Ethernet. Okay, just like from the client, it's a pure layer 3 VPN. But actual implementation, it makes very big difference whether, for example, layer 3 VPN is T constrained or not, and other things. Right? So it requires different models and different control mechanisms.
Just a second. We are stealing some time to the next presentations, but I think this is a pre-requirement to the next presentation. So I would keep on discussing if the presenters of the next slots have nothing to complain about. Okay, let's go ahead.
Okay, Deborah speaking individual, no hats. Laura, go to the one where you're showing your mesh network. Okay, so I think people are just concerned that at those intermediate nodes you're showing switching of the flexi clients, and I don't think you're doing that, but I guess what it would come down to is how you advertise the bandwidth. The flexi is capable of optimizing better for different bandwidths instead of nailing up a whole, say, 100 gig on a wavelength. It's able to do more granularity. But I guess Julian and everybody said that we would not look at necessarily having to prefer a flexi route in that it's flexi. The preference would be more that you would have better bandwidth optimization for those links. So when it's advertised, you would be able to see that you could support this intermediate rate. And so it would be not so much that it's advertised as flexi, it would be advertised more that it can do this granularity of bandwidth. So I think, you know, it's just as when we had SDH signal, OTN signal, you advertise different granularities that you could support. And that's what people were looking for in their routing tables. So here, that's what I'm thinking is, it's not so much that it's Flex E you want to advertise the types of bandwidth that can be supported on that link. And that's what you would go hunt for then.
So you're saying based on a Flexi client, you can advertise bandwidth. Okay, so one is nodding, one is shaking your head. Good.
Okay, so the way I understand this is you wouldn't advertise it as a Flexi client. You would advertise it as an Ethernet link with very good QoS characteristics. Things that could hit a very fine level of jitter, a link that could hit a very fine level of latency, things that could handle a very strict QoS policy. But it's Ethernet, and it gets advertised and propagated through the routing and the control protocols as Ethernet, which we can already do today, right?
And you can actually,
and
you can actually, on what is basically the Flexi group down there that you don't see, you can actually advertise more than one chunk of bandwidth.
No, because
one per Flexi client.
No, because then it shows up as more than one Ethernet link. To Chili's point, there's nothing to grab onto the Flexi group. There's nothing exposed to grab onto and advertise. I can't send it in routing. I can't send it in a signaling protocol. To Igor's point, yeah, the orchestration would be different. Why? Because it's in the interface configuration that I configure the Flexi groups and the channels and associate them together, not in the control protocol and not in the routing. So it's very static. It can be changed, and then that can be reflected into the routing, into the control protocol. But as far as I understand, OIF Flexi, it's configured, and it's point to point.
Yeah.
This is the most complex session since MPLS-TP.
Okay, thanks.
Okay, I think we deserve law at least a polling. So, even if it's really, really difficult to understand which question to ask. So, how many people believe we should work on Flexi? In general. Now, what's the next question? Is this... take the poll into the... Yeah.
The next question in my mind would be how much extra work is there to do over the top of the GMPLS supported PBBTE or GMPLS supported Ethernet that we already have?
So, no, let's make it simpler.
So these get going, Juniper. Just maybe a feedback also to Loa. So when I saw his initial slides, not this one, everything before, I thought, okay, let's extend LNP. So we basically can set up the endpoints for Ethernet, and we're all done. What confused me in that presentation and also later discussions to create a kind of a network layer out of it by selecting everything. So again, from my perspective, adding it to LNP should be kind of straightforward, and I would add that for this kind of connectivity, I'm a little bit more reluctant whether we should pick it up.
So Dave Seneca Erickson again. At the risk of confusing the situation even further, there is work on a Flexi switch technology. Flexi switch, for tie system, right? A Flexi switch sublayer. That would be something that we would possibly look at Ccamp to create a control protocol for. right? But there's a whole lot of extra work. There's a whole lot of work that needs to be done in study group 15 first.
Okay. And the name is the same, it will be Flexi?
No. The name there is called G.MTN, Mobile Transport Network. Yeah.
Okay. That which is switched while Flexi is not. Which is switched while Flexi is not.
It's a switch sublayer. Think of it as a new type of OTN, so to speak. Loose.
But this is not what LOA's document is covering.
No.
Okay.
Let me add some.
Last.
Okay. Add some discussion. Actually, in RTOT, the Flexi is defined as a second layer of MTN.
Okay. Guys, I'm sweating. Let Fatay and I have some thought of it offline, and then we will discuss on the list. Let's go to the next presentation.
Hey everyone. Oh. Does it better? Okay. Hello everyone. This is Michael from Huawei, and not as the author, I helped my colleague Yuan Long to present this document. This document is talk about young data model for Flexi interface measurement. Okay. If we want to configure Flexi interface, so there is some requirements on Flexi management. We need to configure the Flexi group as a network interface, the bonding multiple Flexi physicals, and configure of the Flexi client and mapping to slot in Flexi group. And we also need to provide the ability to drive the Flexi's status, include the Flexi group, Flexi physicals, and the Flexi client. Also, we need to support the interface management in implication of both SDN and distributed routing. And we also to support Flexi 2.0 and also want to support backward compatible with Flexi 1.0. So if we agree with that, the Flexi is some kind of interface, so we should do some work like the young data model for interface. The young IETF young data model, interface young data model is designed following the following characteristics. It defines the streaming of network traffic, and it's an anchor point to apply features and protocol forwarding configuration streaming traffic. And it also defined an interface type, which present in the RFC 7224, and its status such as characteristic can be mentioned. Okay, here is our design of the hierarchy of interface in Flexi. We define two blocks. Is Flexi group and Flexi client, and its management as an interface, and it both are argument for IETF interface module. Client is actually containing Flexi group, and it can be configured with or resized for some Flexi slot. This is our young model trees, and okay, this is what we have do after previous last IETF meeting. We because Flexi client is decoupled from Flexi physical, so it is modeled as a new type of interface. So new Flexi client can be more appropriately modeled and easy to be augmented to support more, some new market layers features such as a flow control. And we want to keep this module simple, so we remove the data plane's internal implementation depending on the artifacts, such as a Flexi instance, render A and B, and we also add two new authors who work for Fiber Homes. Okay, this is some, I know some even though I'm not the author of this draft, but I still review, okay, there's a working group status, and okay, there may be some another works do the Fluxy interface module. So here is some comparison with this module. And we'd like to coordinate with another document authors, and we analyze this difference we present here, and we'd like to post this difference on the mailing list, and maybe the working group and another folks can help us to present their idea and give us some comments. Yeah, the next step. This is the last slide. So, okay. Yes, I have seen. I'd like to coordinate with authors, and but I think there are quite different opinions. So maybe we currently we will decide to update the document in our way, and the working group may help us to make a decision how these works shall be processed. And would like to call more people to help us to review this document. Thank you.
Chile from the Can you go back to slide 7?
Okay, this is it. 7.
So for the difference, okay, I'm one of the authors of another draft. For the difference, I guess if we can figure out which one is better, then maybe there's no need for me to present another view.
I know.
First, let me draw your attention to bullet 4. For instance, calendar A and B are not module.
Okay.
Okay. I will give some comments. The flash instance is module because there is one case that we need to check the mismatch of the instance. Okay, I will give you an example. For the interworking case, for the left side, it's a 205 with 100 gig instance at the south side and 105 at the destination side. In this case, I'm asking we need to check the mismatch of these two flash instances. That's why I think we should include this in the modeling. I checked with this with some guy from question 11 in IETF, actually it's from your company. They told me that we need to add some management information about the flash instance.
Okay.
Sorry. And yeah. Okay, let me finish this one. And for calendar A and B, I think there is an explicit management requirements document in RTOT 3.1823. That this is needed, especially in the case of calendar reconfiguration. We need to make sure the consistency where you just change.
What do you want to use is calendar A and B? You want to do some configuration data transaction? Data transaction to verify whether this data can be configured, correct? Correct? Does it correct? What the calendar A and B do? Because I'm not the expertise on Fluxy, do some work on young modules. So
yeah, it's kind of reconfiguration. Maybe sometimes you need to.
Actually, I'm sorry. So actually, your presentation is relevant to this one, and you are the last one. So we have only 8 minutes. So I'm sorry to say that we have enough time to have fun. So actually, time is always limited. So
first, I'd like to answer this question.
I would suggest let's have more discussion after Chile's presentation, right?
This question I can. Okay, so the first is because if your module supports the NMD architecture, the young modules NMD architecture also can provide the ability to help you to do the configuration transaction. It can help you intended data store. In intended data store, it can help you to verify whether this data can be configured, whether it can implement in the operational data store.
I'm talking about verify the data from the source to sink. It's not verified.
So, but if you use the reconfiguration, how about you have
okay, guys,
all of this
David, can I cut the queue? Okay.
Okay,
thank you. Yeah.
We have a remotely Yuan Long, which tried 3 times. If it's if it's short, you can make a comment, Yuan Long. And if we manage to make you speak, click.
Thank you, Chairman. Can you hear me?
Yes.
Yeah. Firstly, that young module itself already have multiple data store capabilities, such as the startup candidate running such things. So we don't need to repeat it in the configuration. Another point is, if you dynamically add a new client, usually it's done in sequence. You cannot do it on the same day, on the first day. If you do it one by one, for example, today and the next week, then you can send the 2 configurations in sequence, and the data plane can still regard the previous configuration as calendar A, and the new configuration as calendar B. So it doesn't matter we provided it in the configuration module as a calendar A or calendar B. That's my point. Finished.
Thanks. Quick reply, and then we move on.
No, sorry. So Dave Sindekrop again, not from Ericsson, but I'm speaking as the liaison manager of BBF. There is work in the broadband forum that is waiting on some sort of Yang model to be able to configure and manage Flexi interfaces.
We'll have to wait for a
Yes,
while.
I'm seeing that. I just wanted to make the group aware that there is work that is waiting for this. Whether or not it ever comes to fruition or not is a different.
I already feel I will be sick in Singapore.
So we're holding our breath.
Okay, thank you. This is Chile again. For this presentation, that's some data model that we propose for Flexi. Next, okay, this is the content of this presentation update of the draft progress in OIF and IETF study group 15, and comparison with the other draft, and answer to a question in the minutes and next step. And for updates, we just, I think there's 3 major points. The first one, I add some expected values of Flexi, like a group number, like a client number. I think this can be used in the case of mismatch checking. And the second one, we add 2 configuration mode for Flexi client. It could be master slave mode, or it could be static mode. We got this requirement from Cisco, from some chip vendor that we should do this. We also found some related information, related description in Flexi AI. And the third one, we add a Flexi client slot location information. We would give some analysis why we want to do this. We also add a new author from Cisco. And for the Flexi analysis draft, they were updated accordingly to help understand the modeling. And next, this is the client location slot location information. We did worry about this a lot because it was the first time we don't want to put this information into the document because we are thinking about it's different layer or it's similar layer. Okay, after some discussion with the guys from RTOT, also we got some information from Flexi data plan editor that we currently think that same as the Flexi group, the Flexi client has a semantics of Ethernet 5. So we think, okay, just from network point of view, both Flexi client and group that exist in the same network layer, it can be aware of the existence of a slot. That's why we could do this in the modeling. And next, we add some expected module value, like the expected group number file map of calendar configuration. We just use also to do the mismatch mapping from different level. And for the right side of this slide, that we add 2 configuration modes for Flexi client. it's mentioned in FlexCRA from some description there, but currently it's not in Z.8023. I got some feedback from question 14. We should talk about this with question 11 to go to the information why, to go to the information of their understanding. Currently, we add two modes. The first one is static mode. We just use the Control 2 to configure both the transceiver side and the receiver side. And for the second mode, we just it's master slave mode. We just use to configure the source side, and the configured information can be conveyed to the destination through the overhead. And currently, this is the update. And for the recent progress in OIF and ITUT style group 15, I think there is no public progress in OIF. Currently, they are working on RA 2.1 version, but not published yet. And for that group 15, I think they consented the Z.823 amendment 1 to include the FlexE RA version 2, that is the FlexE instance. And we also submit a FlexE model contribution to the management question 4.
Sorry, so we don't have time. Could you just move to the next steps?
Okay.
Just move to the next steps, yeah.
Okay, one answer to a question in the mailing list that what we define is not global, it's also some local scope. Okay, next step, we think currently the requirements is quite clear. We have a lot of discussion about this. We include with FlexCRA data pipeline editor, with also some guys from question 14, question 11. I think it should be a good start, from my understanding. Thank you.
Thanks. Dave Sennekrop now speaking from Ericsson. This model seems more consistent with my understanding of FlexE. And my question is, have you confirmed this with OIF? Have you run this by OIF? I showed you went by your slide when I told you to move forward, but I was reading that. So is this confirmed to be like a model that would reflect the OIF FlexE 2.0 interface?
Actually, with the guys from OIF, how to say that?
What's missing in the work that I'm familiar with is a model to be able to configure via Yang a FlexE 2.0 interface.
Yeah,
that's what's missing. So I was a little distraught at the previous draft that said that they were defining FlexE as a new type of interface, because really it's an Ethernet interface like you presented here, right? So this seems more in line with the understanding of the folks that I know that are progressing more.
Okay, thank you.
Actually, this comment applies to both this presentation and the previous one. We understand that there are related work in both OIF and ITUT, but the more important thing is we also need to design a Yang model that fits into the whole IETF Yang system, and we need to look into other Yang models specified here. So as far as I know, I didn't see any directly augmentations to other models. So maybe we should evaluate on this from common model.
Okay, thank you.
Last one.
So pertaining to the last comment, my understanding is that having a model that would be compliant with and fit into the IETF Yang model structure, and having that same model fit into the data modeling, information modeling coming out of study group 15 may be mutually exclusive.
Okay, I received a email from my colleague, and seems there are quite different. There are quite a lot of issues. So maybe we are for the model design. Maybe there are a lot of issues we should further discussion. So I think that we need a FlexE Yang data model in this IETF, but I don't think we can do this work based on this document.
So far, I don't see any big agreement on none of the documents.
I would disagree with the last comment. I think this would form a great base to start the work.
Okay. Point taken.
Thank you.
Thank you. So thank you for making us wet in such a cold room, and see you in Singapore.